Are you guys ready? I mean, for fall break?
Yes.
How do you feel about having class Wednesday?
Everybody's basically saying that we're not going to have class in all my classes.
Oh, you're lucky.
Yeah, were you watching movies or something?
No, we have a lot of people that have to, travel quite far on Monday to
Uh-huh.
get home.
How about
Wednesday night.
Yeah.
So how about Wednesday we have class by video?
Yeah.
Sound good? Sound like a plan?
Like a YouTube video?
Yes, like a YouTube video of my choosing. Of my choosing, like, watching random episodes of Styropyro will not count for math. Although he does have some math. I've recently learned of this this YouTube channel, which has existed for quite some time. It's called Styropyro, and it's just, I love this. This guy, he gives very cheerful oration of death, like death-defying, dangerous science experiments. Basically, overpowering various lasers and shock-generating machines, building homemade explosives, this kind of thing. It's a lot of fun.
That sounds like fun.
It is a lot of fun. Anyway, I should begin with a word of prayer before I forget. Dearly Father, we thank you for this day again. I thank you for these students. Just ask you to just bless our work today. Help us to glorify you, what we do, Lord. In your name I pray, Lord Jesus. Amen. So, what I'm going to do is, there was a quiz technically scheduled for Wednesday, but I've already had somebody in the other section tell me they have university approved travel, blah, 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 so I just don't want to do it. And so I'm just going to double up the value of the quiz after the break. So we'll have the next two quizzes will be the Wednesday after break, okay? It'll count double, something like that. All right, so I need to talk to you guys about the division algorithm. And the division algorithm is really just a summary of the long division that we've already done. But let me just write it out for you. Whoa. It's that ruler over here. Anyway, so f of x over g of x is equal to p of x plus r of x over g of x. So here, f of x and g of x are given polynomials. All right, do you guys know what degree is? Like, degree is the largest power that appears, right? So if I have like x to the fourth plus x plus 3, the degree is 4. If I have x to the 13th plus 100,000 x minus 2, the degree is, what was the first thing I said? I forgot, but here. It's not about how big the number is, it's about how big the power. So I have like x squared minus a million, kabillion, whatever this number is, x. The degree of that would be 2, okay? It's whatever's the largest power that appears, that's the degree. So in this story, the degree of p of x is going to be equal to the degree of f of x minus the degree of g of x. Now this assumes that the degree of g of x is bigger than, the degree of f of x is larger than f of x, okay? If that's not the case, there is no p of x and there's nothing to do. So like this algorithm only works if the f of x has larger degree than g of x, okay? And then the degree of the remainder, well, that is less than the degree of the dividing polynomial, which I've called g here. So this is the division algorithm that you can do long division to construct p of x and r of x and g of x like so. Let's give an example. So I can take like x to the fourth, and I can divide in, say, x plus 2. All right, and we make it x to the fourth plus x minus 2 there. That's not minus 2. It's too much like the 2 I already got there. So put a 42. You can always use another 42 in the problem. All right, so there we go. general point of order, if you're working on my test and you find the answer is 42, you probably got it right. Right? I mean, I do often try to reverse answers to be 42. Now, don't just guess 42. That does not delight me. I mean, it's amusing. But if you're going to guess something, you should guess 0. That's more likely the answer. But explain yourself. Don't just guess. Anyway, so first of all, to get this x to the 4th, I must put an x cubed up here. All right? X cubed times x plus 2 gives me x to the 4th plus 2x cubed. All right. And that's annoying because I couldn't line up the powers. Be careful here. This is going to give me minus 2x cubed plus x minus 42. Notice that I cannot subtract x cubed from x, right? They're not common term. They're not common powers. We can only subtract matching powers. Okay. Then what? I got a minus 2 down here. So what do I do? Negative what? Negative 2x squared. Yeah, we want that. Negative 2x squared gives me minus 2x to the 3rd, and then a minus 4x squared. And then be careful again here because, you know, I can't subtract the x from the 4x squared, right? So what I get is a 4x squared, minus minus is plus, plus x minus 42. All right, now what? Well, what? Wait, what? But it's an x and an x squared. See, that's the point, is I can't combine them because they're different powers. I'm sorry, this red is... Oh man, that was really, really far off. I had to fix that. Dodge that. All right, so then we want a plus 4x, and that gives us 4x squared. 4x times 2 gives me 8x. Finally, we've got something to get rid of that x. All right, obligatory Taylor-Swift joke. Let's see here, minus 7x minus 42. Insert your own Taylor-Swift joke right there. And then what? I'll finish it in purple. I need a minus 7 up here, right? So that gives me a minus 7x. And what's 2 times 7? 14, right? So minus 14. Careful of the minuses. It's 42 minus 42 plus 14, also known as negative 28. I think so, negative 28. So what does this all mean? This all means that x to the 4th plus x minus 42 divided by x plus 2 is equal to what? Well, it's equal to x cubed minus 2x squared plus 4x minus 7 minus 28. Well, plus minus 28. I guess I could put the minus up front. Fine, minus 28 over, what's my x plus 2? So that's what this calculation means. And just to frame things in terms of the language that I just used, my p of x, right, this right here, is exactly all this business. This is my p of x, right? The remainder was minus 28, right? And so this was playing the role of my dividing polynomial g of x, and that was the polynomial which was being divided, f of x. Any questions? I think we're at about our 4th long division at this point, right? We'll do a few more. Now, what does this mean? So we could leave it like this, right? But we could also point out that this means that x to the 4th plus x minus 42, which of course is equal to f of x, okay? It's also equal to x plus 2 times x cubed minus 2x squared plus 4x minus 7 minus 28. So, I mean, if you look at this equation, it does tell you certain things, right? Like what? It tells you that x plus 2 is not a factor of f of x, right? Can you tell me anything else it tells you? What's the significance of the remainder? Why is the remainder minus 28 here? What does that mean to f of x? Well, that's what the remainder theorem has to tell you. So this is the remainder theorem. And the remainder theorem simply says this. If R is the remainder of f of x divided by x minus c, then R is equal to f of c. And we can prove the remainder. I don't prove many things in here, but I'll prove the remainder theorem because it's not hard. It's actually really easy. All I do is I take the result of the division algorithm, which is what? So I take f of x over x minus c. That's equal to p of x plus r over x minus c. Now you guys tell me, if you believe the division algorithm, why does that r have to just be a constant? What's the divisor here? The divisor is x minus c, right? What's the degree of that? It's degree 1. The only thing with smaller degree than 1 is 0. You can't have negative degree, in here anyway. And so that forces this just to be a constant. Well, multiply by x minus c, what do you got? You got f of x is equal to p of x times x minus c, right, plus r. And what happens when you plug in f of c? What happens when you plug c into that equation? What do you get? We get p of c, right? What's c minus c? It's 0, right? So that formula right there just simplifies simply to r. F of c is equal to r. And that's the remainder theorem. And so if we go back to my example 1, what's f of, what's f of minus 2? Well, it's equal to minus 28, allegedly. Can we check it? See, we can check our long division by actually evaluating the function at minus 2. Can you guys evaluate that function at minus? Oh, thank you. I could have saved myself the trip. So can you calculate it directly? What is f of minus 2? Minus 2 to the 4th power, right? Minus 2 minus 42. What's that equal to? We got ourselves a 16 minus 44, also known as negative 28, I sure hope. Right? Yeah. Oh, because we're dividing by x plus 2. So the 0, which corresponds to this factor, is minus 2. Remember? And so this is actually how the factor theorem is proved. What was the factor theorem? Do you guys remember? Factor theorem says what? It says f of x is equal to x minus c times some g of x, right? In other words, x minus c is a factor if and only if what? If and only if f of c is equal to 0. So this, of course, the context here is polynomial. For a polynomial, x minus c is a factor only if f of c is equal to 0, right? Well, that makes perfect sense if you think about dividing. If you divide f of x by x minus c, you get g of x, right? And that would only be the case if the remainder is 0. But what is the remainder? Well, the remainder is exactly f of c, so it has to be 0. So anyway, the factor theorem is actually proved with the remainder theorem. Not that I'm going to ask you guys to prove any theorem in here, obviously, right? I'm not a monster. Example 2. Let's try another one. Goodness gracious. Let's see here. I top hatted in the last section, so I should actually take attendance in this one. That way it's slightly asymmetric. I'll let you add a date. Oh, wait a minute. You don't have a pen? Someone here has a pen, surely. Haha. I'll find a pen for you. You got a pen? Oh, okay. Okay, so example 2. Let's just do another one. So let's say x minus 1 divided into x cubed plus 3x squared minus 7x plus 10. All right? We'll just work this one out. Okay, so what do we start with here? X squared. All right. So we get x cubed minus x squared, right? We take the difference. What's that give us? So minus and minus gives me plus, right? So I get plus 4x squared. Then what? Well, and then I should bring down the 7x and the 10, right? What'd I do? Then what? Plus 4x. Okay. So we get 4x squared minus 4x. We take the difference there. What do we get? Minus 7 plus 4. I think that's a minus 3x plus 10. And then what's that give us? I heard a minus 3? I'll allow it. Cool. All right, so minus 3x plus 3, right? Subtract those. The minus 3x, of course, cancels by construction, and 10 minus 3 is 7. 7 has a smaller degree than x minus 1, which means we're done. That's the remainder. And what does this all show us? This shows us that x cubed plus 3x squared minus 7x plus 10 is equal to, as it happens, x minus 1 times x squared plus 4x minus 3 plus 7. And this is a formula for f of x, all right? Okay, great. Now what? Well, we could plug in 1 and see what happens. What should happen when we plug in 1? What's f of 1 equal to? It should be equal to 7 because this first bit goes to 0, so it's like 0 times stuff plus 7, which is equal to 7. But on the other hand, we can go back up and just plug in 1 here, right? 1 plus 3 minus 7 plus 10, which equals what? (14 minus 7, which is 7, right? So it checks. Anyway, this is the remainder theorem. The remainder should be equal to the value of the function evaluated. Now, this only works really directly if what? If we've got like a linear factor. If we have like a quadratic factor, you got to use your imagination a little bit more. So, example 3, I'll try to keep this one relatively simple. Let me keep really simple. F of x equals x to the 4th plus 6x cubed plus 10x squared plus, we'll add a 42. Why not? All right, so there you go. Oh man, what did I just, yeah, a question?
No, I was just.
Oh, okay. That is much like asking a question. It's funny, but all right. So anyway, let's see here. So let's divide by x squared plus 6x plus 10, the given f of x. Let's see what happens. Let's see what happens here if we do that. All right. Let's see here. So I do what? I guess I put an x squared, right? And that may be it. So then I get x to the fourth plus 6x cubed plus 10x squared. Well, this is going to be a very short calculation, isn't it? And so that leaves us with a remainder of 42. All right, wonderful. That was that was a pretty oh, you got it. Okay. Well, it was a pretty short long division. Then what? Well, what does this mean? This means that f of x is equal to, apparently, x squared plus 6x plus 10 times x squared plus 42, which is kind of obvious anyway, right? If you just look at the formula we started with, it's really easy to see how I came up with this example, if you want to think about things. Now, I want to point out something more about this, which is, if we look at this, this is what? Complete the square. X plus 3 squared plus 1 times x squared plus 42. So that quadratic that we divided out, where is it 0? You guys tell me, like x squared plus 6x plus 10 equals to 0 is the same as what? X plus 3 squared equals to minus 1. So the solutions are plus or minus I. In other words, x equals to minus 3 plus or minus I. Those are the solutions to that quadratic equation, right? Do you guys see that? So my question is, what happens if we look at f of, let's say, f of minus 3 plus I? What's that going to work out to? So we've got, minus 3 plus I squared plus 1 times minus 3 plus I, the quantity squared, plus 42. I'm just plugging minus 3 plus I into the formula we just derived. No, yeah?
Sorry, wouldn't you put a plus 3 after the first part of 3 plus I? Because in the x plus 3 squared. Or am I just...
Oh, I'm just not writing enough. My bad. So look, so this complete this square is x plus 3 squared, right? Minus 3 squared, which is 9 plus 10. And then, so that's why I have x plus 3 squared plus 1. Like, that's what completing the square looks like on this one. Is it just, there's a 9, there's a...
Sorry, I meant after the minus 3 plus I. After that, before the square.
Oh, yes. Thank you. My bad. You knew that. Cool. Very helpful. Yes. That's important because what happens? The 3's cancel, right? And you're just, this is just what? This is I squared plus 1, right? Of course, this is all very dumb because what did I just show over here? I showed that if you have x squared plus 6x plus 10 and you plug minus 3 plus I into it, what happens? You get 0. So this mess right here is 0. And I don't care if this is non-zero. The point is 0 times 0, 0 times anything, 0. So all we're left with is that. So the answer is 42. So there's a problem kind of like this in your homework. I think it was like 60, it was part B of like 59 or 62. I can't remember which one, but there's a problem based on the same kind of idea. All right. Okay. Now, here's the more horrible thing. Think about plugging in example 3, right? Think about the annoyance of just going back to the original formula and just plugging minus 3 plus I into that. See how much more horrible that would have been? If you just plug this complex number into that formula and work it out, somehow all the stuff with x works out to be 0 and just leaves you with the 42, right? But it would be a much harder calculation to just do that directly. Just saying. Okay, so listen, we can do more long division, but I think at this point you're probably starting to get bored with me doing long division. I know I am. And so I want to shift gears and talk about how we can construct polynomials that have certain features, and also how we can graph polynomials, all right? Because that's the other sort of big looming topic. And the whole problem of long division is really just to aid us in our understanding of factoring, okay? But so I need to talk to you about some terminology before I do anything else, which is multiplicity. And I think multiplicity, I think we've actually already talked about this, but let me just show you an example. I guess we're on example 1. We're on example, what, 4? 3? 4. Okay, 4. So let me just show you, I think this example probably will suffice to give you the idea of multiplicity. If we have f of x is like x plus 3 to the power 4, and then say x minus 10 squared, and then x minus 8. That ought to do it. So let me just talk about the factors. Okay, this one has multiplicity, what? Multiplicity 4. This one right here, multiplicity 2. This one here, multiplicity 1. So we talked about multiplicity when we talked about the sign flip theorem, right? How to create the plus minus chart, to solve the nonlinear inequality. We already talked about this idea there, but I want to talk about it again. All right, because I want to use this language for my next example. Example 5. Here we go. Construct polynomial of least degree with y-intercept of 100, all right, and a 0 of, let's say, minus 5 with multiplicity 2, and a 0 of 4 with multiplicity 3. So I would also say in my previous example, like we could write the following sentence, okay? So this present right here, this means that 8 is 0 of f of x with multiplicity 1. So to say something is a 0 just means this: f of c equals to 0 if and only if like c is a 0, or root of f of x. Okay, that's the language. All right, so you guys help me out. What should I write here? I'll do the easy part. F of x. There you go. What should my formula be? Now if I, notice I have a minus 8 here. So if I have a minus, if my 8 is a 0, so it's the whole factor theorem, right? So I need an x plus 5, right? To what power? Squared, okay. And then what? X minus 4 cubed, right? And I can't just do, now some of you want to make me just write plus 100. That will ruin everything. We can't do that. Because if I do that, then that doesn't, then this won't go through 0 at minus 5 and 4. But there is something we can do, which is multiply it by an a, which we don't know yet. So we just put a constant there. That doesn't change where the zeros are, right? So the factor theorem comes into play here. Factor theorem says, oh, okay, so this has f of minus 5 is 0 and f of 4 is 0, right? And we obviously have the multiplicity. You can't make the multiplicities less and have the multiplicities as desired. And you can't add anything else to this. Otherwise, you would not have a polynomial of least degree, right? So this has to be the form up to our choice of a. Now, how do we figure out what a is? What is y-intercept? What's that mean? Where is y-intercept? It's at when x equals to 0, right? So I plug in 0. F of 0 is equal to 100, but what else is it equal to? Well, it's also equal to a times what? Yeah, 0 plus 5, right? 0 plus 5 squared times 0 minus 4 cubed, which is really what? A times what? Kind of a big number. 25 times, is that 64? Is that minus 64? So, yeah, minus 64 times 25, which I think is, sorry, minus 1600, is it? Like if I peel off 4 of those, I get 100. What's 4 times 16 is 64, right? So I'm pretty sure that's minus 1600. Somebody can check me on that, but. All right, so then A is equal to? Apparently minus 100 over 1600, also known as minus 1 over 16, right? And so answer, f of x equal to minus 1 over 16 times, x plus 5 quantity squared, x minus 4 quantity cubed. And there you have it. That answers the question. There's a bunch of problems like this in your homework where I tell you like a 0, its multiplicity, and ask you to build the polynomial, which is like that, okay? Let me do another one of these. What? No? What? Oh, okay. All right. All right, so let's talk about graphing polynomials. So if you want to graph, here's the process I recommend. Number 1, you factor f of x if plausible. I mean, there are times where you just can't factor f of x, and you just kind of, maybe there's some other kind of sneaky way you have to proceed. But if possible, factor f of x. Number 2, you draw a sign chart. Draw a sign chart for f of x. All right. Group common factors, right? So you need to group your common factors. You need to identify multiplicities in that factoring process, okay? Like if you've got x plus 1 2 different places, you need to put them together so you can see that you've got an x plus 1 squared, all right? You draw the sign chart for f of x. Step number 3, gather any easy data. And by that I mean like, y-intercept or etc. And also in this regard, you either have got like the degree of f of x is even, or you've got the degree of f of x is an odd number. If it's even, it either looks like this or like that. If it's odd, it either looks like this or like this. Oops, my bad. Like this. I'll get it eventually. Like this. So this is like, a sub n greater than 0, a sub n greater than 0, a sub n less than 0, a sub n. Excuse me. Yeah, a sub n less than 0, a sub n less than 0. So here I'm talking about the leading coefficient is either positive or negative. If the leading coefficient is positive, then it looks like a bowl which goes upward. That's the big picture. Or it looks like a bowl that goes downward if the leading coefficient is negative. On the other hand, it looks like a sneaky snake, like an S that goes like this if your leading coefficient is positive. If it's negative, it looks like that. So these are all big picture. In other words, I'm ignoring the finer points in that general shape, but that's what you have to look forward to. That's what it looks like in the big picture. And then for graph. So let me just actually put that into practice for my example 5, okay? So like my example 6 here. So for example 5, I had, what were my zeros? -5, right? And 4. This is for f of x equals to, was it -1/16? X plus 5 squared times x minus 4 cubed, yeah. Listen, so what's the leading, the a sub n in this thing I was drawing over here, a sub n is the leading coefficient. Leading coefficient. So that's the number that's in front of the biggest power of x. Like what's my leading coefficient for this one? If you multiply this out, what's it look like? There's a -1/16, and what's the biggest, baddest power of x you got in this formula? You get an x squared from the first factor, right? And you get an x cubed from the second factor if you think about multiplying it out. So you don't need to multiply it all out. You can see without doing the whole multiplication, you can see that that's x to the 5th, right? And then you got stuff, who cares what it is. But I can tell you that what the constant coefficient, I can tell you what it is. It's 100 from our experience in the past. So this when you multiply this all out, you get 100. Great. So so by the way, multiplying the polynomial all the way out and grouping like powers, that's called putting it in standard form. If I ask you to put it in standard form, that's when I'm asking you to multiply it out. If I don't ask you to put it in standard form, then by all means do not multiply it out. Right? That's why, did I multiply this one out? I did not, because no one wants to see that. And this is actually a better formula in example 5 than if I multiplied it out. However, multiplying it out does show me some things, like if it's multiplied out, I can tell you that's the y-intercept, and I can also read off from this that my a sub 5 is equal to -1/16, which is less than 0, which means that the big picture of it looks kind of like this. All right? All right, so you guys help me out. Can you help me fill in the sign chart? What would happen if I put 10 into the formula? This would be positive. That would be positive. That's still -1/16, right? So you got negative times positive, it's negative. So we've got a negative over here. And the multiplicity of minus 4, I mean, if multiplicity of 4 is 3. It's a cube. It flips. We got pluses, right? How about minus 5? Multiplicity 2 would bounce, right? And when I said bounce, this is where I was actually talking about that terminology actually starts to make more sense. So what's the graph look like? Well, here it be. Now this is a sketch of the graph, all right? So it's not, this is not to scale in both axes. I'm just trying to capture the main features, which are like, the x-intercepts essentially, and the nature of the x-intercepts. So there's one at 4, and the other one's at minus 5, right? And so I've been saying that it bounces from time to time, and this is really where I actually see the bounce. So check it out, right? Like this. Here it comes in. It's negative. I mean, it seems positive, and then it literally bounces off the axis like that, right? And then apparently it has to turn back around, right? Because it crosses at 4. So it's got to do like this. And there you go. That's the graph. That's what y equals to f of x looks like. And of course, we could, I don't really know where this hump is. I have no idea. Okay? Like, to figure out where the hump is, where it stops going up and starts going down again, you need calculus for that. All right? Because that would be the place where it stops going up and starts going down again is the place where the derivative is 0. But do we know what a derivative is? We do not, right? That's forbidden knowledge to us, forbidden fruit. So, but I do know that the y-intercept is 100 for this one. So obviously this picture is not to scale, right? In other words, like my y coordinates and my x coordinates, definitely not in the same scale, But this is a sketch of the graph. If I ask you to sketch the graph, this is the kind of picture I'm talking about. A picture which contains meaningfully the behavior of the different roots. So let me show you another example. And I didn't get to this kind of example in the other section, so this is just for you guys. But now I'm going to turn the tables. I'm going to give you a graph. I'm going to ask you to tell me a formula. All right? So what if I give you a picture of a graph and I say, find me the polynomial formula of least degree which has that picture? So here it is. Suppose our graph looks something kind of sort of like this. You bounce, cross, back up again. There we go. This is kind of a horrible example. Perfect way to end the day, I think. And I'm going to really regret doing this, but let's make that at 10. All right, and you guys can tell me where is it bouncing? Let's see here. This is what? What do you guys feel like this is? Minus what? I heard a minus 5? Okay, fine. I'll allow it. If that's minus 5, this is going to be 4. This is going to be 8. This guy over here is going to be 13. And I don't know, that feels like a 42. Okay. So what is the polynomial of least degree which has a graph that looks like this? Up to a sketch. I'll write it down. So we have f of x is equal to a. I don't know what a is yet. A. It crosses at minus 5. So that puts, the least I can get away with to get that is x plus 5. I could have x plus 5 to the 3rd power, or to the 5th power, or 7th power, 17th power. It would still look like that, give or take, as it crosses 5. But certainly, that's the smallest factor I can get away with to make it cross, okay? And it bounces at 4, so that puts an x minus 4 squared, right? And then it bounces at 8, that puts an x minus 8 squared. It crosses at 13, that puts an x minus 13. It crosses at 42, that puts an x minus 42. And there you go. So if it bounces, you want a even factor to get it. If it crosses, you want an odd power factor to get it. Of course, we could also make it like to the 4th power or to the 3rd power, but this is the starting point. Yeah.
Why is x minus 4 x minus 8 Why are they squared?
The difference between 4 and 8 and the other ones is that it's bouncing. It's just bouncing off the axis here. See, the other ones, it's crossing. Now, how do you figure out what A is? So f of 0, right, is 10. But on the other hand, it's also what? A times 5 times 16 times 64 times minus 13 times minus 42. So apparently we just choose A equals to 10 over, well, I can cancel the 10 and with a 5, that gives me a 2. 2 over 16 times 64 times minus 13, well, times 13 times 42. And you just take that, put it back up in there, and that's your example. So anyways, you guys have a good break, okay? And do watch the video when you get a chance. Thanks, guys.